It is difficult to deny that something out of the ordinary is occurring with the weather in 2023, given global temperatures that are record-breaking and the tremendous rainfall that has been occurring. People have been quick to blame climate change, and they are somewhat right in doing so. The largest contribution is played by global warming that is driven by humans. A recent analysis concluded that the week-long heat wave that began in June 2023 in Texas, the US Southwest, and Mexico would have been almost impossible without it. But this year's extremes are more severe than what would be predicted to be caused by global warming caused by humanity on its own. According to the Earth Observation Programme of the European Union, the month of July was the hottest month on record for the planet Earth by a significant margin. Average worldwide temperatures were more than half a degree Fahrenheit, a third of a degree Celsius, over the previous high, which reached the record in 2019. Temperatures have been progressively climbing as a result of human activity, generally at a rate of roughly 0.2 degrees Fahrenheit, 0.1 degrees Celsius per decade. However, there is more than human activities that is causing this event. Let's dig deeper. When observed from a significant distance, the Sun appears to possess a tranquil and unwavering nature. Upon closer examination, it becomes evident that our celestial body, commonly referred to as the Sun, undergoes a continuous process of change, transitioning from a homogeneous expanse of incandescent matter to a disordered amalgamation of distorted plasma, and subsequently reverting back to its original state in a repetitive pattern. Approximately every 11 years, the magnetic field of the Sun through a process wherein it becomes intricately entangled, resembling a tightly coiled collection of rubber bands, until it reaches a critical point and abruptly undergoes a complete reversal, resulting in the North Pole transforming into the South Pole, and vice versa. Prior to this significant turnaround, the Sun intensifies its activity by generating flaming blobs of plasma, developing large black areas comparable to planets, and releasing streams of potent radiation. The period characterized by heightened solar activity, commonly referred to as solar maximum, poses potential risks to Earth. During this time, the planet is subjected to solar storms that have the capacity to disrupt communication systems, cause damage to power infrastructure, pose threats to certain organisms, including astronauts, and result in the fall of satellites towards Earth. There is speculation among experts that the forthcoming solar maximum may occur earlier than previously anticipated and possess far greater intensity. Initially, researchers made a projection indicating that the present solar cycle would reach its maximum point in the year 2025. However, a substantial yield of sunspots, solar storms, other infrequent solar phenomena indicate the potential arrival of solar maximum as early as the conclusion of this year. Numerous specialists have expressed concerns about our inadequate level of preparedness for this event, as reported by Live Science. What are the factors that contribute to the occurrence of the solar cycle? The Sun undergoes a cyclical pattern of solar activity, transitioning from a period of reduced activity called solar minimum to a period of heightened activity known as solar maximum, with an average duration of approximately 11 years. The precise cause for the extended duration of the Sun's cycles remains uncertain. Nonetheless, astronomers have observed this recurring trend since the inception of Solar Cycle 1, appropriately designated as such, spanning from 1755 to 1766. According to NASA, the commencement of the present solar cycle, Solar Cycle 25, was formally observed in December 2019. What are the factors responsible for the fluctuations observed in our home star? According to Alex James, a solar physicist at University College London in the United Kingdom, the fundamental factor at play is the magnetic field of the Sun. According to James, at solar minimum, the Sun exhibits a robust and well-structured magnetic field, characterized by the presence of two distinct poles, like a conventional dipole magnet. According to him, the magnetic field functions as a substantial force field that confines the Sun's highly heated plasma, also referred to as ionized gas, in close proximity to its surface, thereby limiting solar activity. According to James, the magnetic field gradually becomes entangled. resulting in certain locations exhibiting a higher degree of magnetization than others. Consequently, the magnetic field of the Sun undergoes a steady weakening, leading to an increase in solar activity. Plasma emanates from the stellar surface and gives rise to substantial magnetic structures resembling horseshoes, referred to as coronal loops, which are distributed throughout the lower atmosphere of the Sun. Solar flares are produced when the Sun's magnetic field undergoes realignment, causing the subsequent snapping of flaming ribbons. This phenomenon results in the emission of intense bursts of light and radiation. Occasionally, solar flares also give rise to substantial magnetic clouds of swiftly moving particles, referred to as coronal mass ejections, CMEs. Several years following its peak, the magnetic field of the Sun undergoes a phenomenon known as snapping, resulting in a complete reversal. According to James, this marks the conclusion of the cycle and the commencement of a subsequent solar minimum. In order to figure out the current phase of the solar cycle, scientists engage in the observation and analysis of sunspots. These are characterized as regions on the surface of the Sun that appear darker, cooler, and exhibit a circular shape, serving as sites for the formation of coronal loops. According to James, the emergence of sunspots is attributed to the penetration of robust magnetic fields through the surface of the Sun. Through the examination of sunspots, it is possible to gain insight into the current strength and complexity of the Sun's magnetic field. Sunspots are notably limited during periods of solar minimum and exhibit a gradual rise in abundance until reaching a maximum during solar maximum. However, it is important to note that there is considerable variability observed from one solar cycle to another. According to James, each cycle has distinct characteristics. What is the Solar Cycle 25? The Solar Cycle 25 prediction panel, comprising numerous scientists from NASA and the National Oceanic and Atmospheric Administration (NOAA), issued a forecast in April 2019 regarding Solar Cycle 25. The forecast indicated that the solar maximum of Solar Cycle 25 is expected to commence in 2025 and exhibit a similar magnitude to the maximum of Solar Cycle 24. Notably, the solar maximum of Solar Cycle 24 exhibited an atypical delay occurring between mid-2014 and early 2016, and was relatively feeble in comparison to previous solar maximums. However, even from the outset, the prediction appeared inaccurate. For example, there has been a significant disparity between the observed number of sunspots and the expected values. In December 2022, the Sun exhibited a sunspot maximum that corresponded to the culmination of an 8-year cycle. In January 2023, a notable disparity was detected between the number of sunspots recorded by scientists and the predictions made by NASA. Specifically, the observed sunspot count amounted to 143, which exceeded the expected count of 63. This discrepancy persisted in the subsequent months, with the recorded sunspot numbers remaining consistently elevated. Over a consecutive period of 27 months, the recorded count of sunspots has consistently surpassed the anticipated count. Although the abundance of sunspots is a significant indicator, it is not the sole piece of evidence suggesting the imminent arrival of solar maximum. The number and intensity of solar flares are additional significant indicators of solar activity. According to spaceweatherlive.com, there was a significant increase in the occurrence of C-class and M-class solar flares in 2022 compared to the previous year, 2021. Additionally, there is a rising trend in the frequency of the most potent solar flares, classified as X-class, on a year-to-year basis. During the initial 6 months of 2023, a greater number of X-class flares were recorded in comparison to the entirety of 2022, with the additional occurrence of at least one flare making direct contact with Earth. Solar flare classes are categorized as A, B, C, M, and X, with each subsequent class exhibiting a minimum power level that is tenfold greater than the preceding class. Solar flares have the potential to induce geomagnetic storms, which are significant disruptions of Earth's magnetosphere resulting from solar wind or coronal mass ejections, CMEs. On March 24, an unexpected stealth coronal mass ejection, CME, impacted Earth, resulting in the initiation of a highly intense geomagnetic storm, surpassing the magnitude of any observed event in the past 6 years. This event led to the emergence of expansive auroras, also referred to as northern lights, which were observable throughout over 30 states inside the United States. The occurrence of geomagnetic storms has witnessed a general rise this year, thus leading to a notable elevation in the temperature of the thermosphere, which is the Earth's second highest atmospheric layer, reaching its highest point in the past 2 decades. The occurrence of infrequent solar phenomena tends to grow more frequent during periods of solar maximum, and a number of such events have been observed in recent months. On March 9th, a plasma waterfall with a height of 60,000 miles, 96,560 kilometers, was observed ascending and subsequently descending towards the Sun. Similarly, on February 2nd, a substantial polar vortex, referred to as a ring of fire, exhibited rotational motion around the Sun's northern pole for a duration exceeding 8 hours. Likewise, during the month of March, a solar tornado persisted for a period of 3 days, surpassing the height of 14 Earths when vertically stacked. According to James, the available information indicates that the solar maximum is anticipated to reach its peak earlier than initially projected, and the magnitude of this peak is expected to be bigger than previously estimated. According to scientists interviewed by Live Science, this viewpoint is widely held among solar physicists. The precise commencement of solar maximum is expected to become apparent only after its occurrence, when solar activity begins to diminish. Nevertheless, a research team headed by Scott McIntosh, a solar physicist and deputy director of the National Center for Atmospheric Research in Colorado, has made a projection suggesting that the solar maximum may reach its highest point at a later time in the current year. Based on historical patterns, it is observed that the solar maximum phase potentially spans a duration ranging from 1 to 2 years, but with a degree of uncertainty among scientists. The potential repercussions on Earth. It is possible that the solar maximum is approaching with greater intensity and at an earlier time than previously predicted. What is the significance of that? According to Tsu Fong, a researcher at NOAA's Space Weather Prediction Center who was not affiliated with the Solar Cycle 25 prediction panel, the outcome is mostly contingent upon the occurrence of solar storms impacting the Earth. This statement was made in an interview with Live Science. For a solar storm to impact Earth, it is necessary for it to be oriented in the appropriate direction and coincide with the correct timing. According to the researcher, heightened solar activity enhances the probability of such occurrences. However, it does not provide an absolute assurance that the planet would experience an upsurge in storm frequency. However, in the event that a solar storm occurs, it has the potential to ionize the upper atmosphere of Earth, leading to radio and satellite blackouts. According to Fong, severe storms have the potential to disrupt global communication systems, such as long-range radio and GPS, by obstructing the globe's connections to satellites. This disruption can last for a significant period of time, affecting up to half of the planet. According to the speaker, in isolation, this situation may just pose a little inconvenience. However, if an extended power outage were to align with a significant calamity, such as an earthquake or tsunami, the consequences may be of a disastrous nature. According to Fang's statement, it is evident that robust solar storms possess the capability to generate electrical currents on the Earth's surface, which might potentially cause harm to metallic infrastructure such as outdated power grids and rail lines. According to Fong, there is a possibility that airplane passengers could experience elevated amounts of radiation during solar storms. However, it remains uncertain if these doses would reach a magnitude that could result in any discernible health effects. Nevertheless, the impact of these radiation surges would be considerably more substantial for humans situated within spacecraft, such as the International Space Station or the forthcoming Artemis mission destined for the Moon. According to her statement, it is recommended that forthcoming missions take solar cycles into account. Previous studies have also demonstrated that geomagnetic storms possess the capability to interfere with the migratory patterns of grey whales and other organisms that depend on the Earth's magnetic field lines for navigation, including sea turtles and certain avian species. This disruption can lead to severe and detrimental outcomes. The upper atmosphere, when ionized, has an increase in density, resulting in the generation of increased drag for satellites orbiting the Earth. The additional drag experienced by satellites has the potential to induce collisions between them or disrupt their orbital trajectories. In February 2022, a total of 40 Starlink satellites belonging to SpaceX experienced atmospheric incineration as they descended towards Earth subsequent to their launch, coinciding with a geomagnetic storm event. According to Fong, there has been a significant exponential growth in the quantity of satellites as compared to previous solar cycles. According to the speaker, the majority of satellites are operated by private entities, which typically do not take space weather into consideration when designing or scheduling satellite launches. She also added, there is a strong desire among companies to expeditiously deploy satellites in order to mitigate any potential delays in rocket launches. Occasionally, it may be more advantageous for individuals to initiate a collective endeavor and experience a 50% loss rather than refraining from launching the endeavor altogether. The aforementioned circumstances increase the likelihood of significant collisions or the deorbiting of satellites during the solar maximum. According to her analysis, there is a modest elevation in the likelihood of a rare superstorm occurrence comparable to the Carrington event of 1859 at periods of solar maximum. Although it is unlikely, the occurrence of such a storm might result in significant financial losses amounting to trillions of dollars and have a profound effect on daily routines, as stated by the speaker. Likewise, she also stated that it is challenging for humans to effectively protect themselves against the direct impact of a solar storm. However, there are measures that may be taken to mitigate the potential damage caused by such events. These include adjusting satellite paths, temporarily halting aircraft, and identifying and reinforcing weak infrastructure. According to her, there is a need for more precise solar weather forecasts in order to adequately prepare for adverse conditions. What were the reasons for the inaccuracies in the forecasts? Given the considerable amount of evidence indicating a more robust and earlier occurrence of the solar maximum than initially projected, it is pertinent to inquire why scientists did not anticipate this phenomenon. According to Scott McIntosh, the manner in which the prediction panels generate their projections contributes to the issue at hand. According to McIntosh, the models utilized by NASA and NOAA have seen minimal alterations over the course of the past 3 decades, although the scientific understanding and knowledge base have significantly advanced. According to the speaker, the models incorporate historical data pertaining to solar cycles, including sunspot number and cycle length. However, it is noted that these models do not comprehensively consider the distinct course of each unique cycle. According to McIntosh, the situation might be likened to a significant game like pin the tail on the donkey. In this analogy, the donkey represents the forthcoming solar maximum, while the forecast panel has metaphorically blindfolded themselves by neglecting to utilize all the accessible options at their disposal. McIntosh and his group have presented an alternate methodology for forecasting the intensity of an impending solar maximum. This approach involves the examination of solar terminators, which manifest at the conclusion of each solar minimum subsequent to the reversal of the Sun's magnetic field. During periods of solar minimum, a regionally confined magnetic field, resulting from the reversal of the Sun's magnetic field, envelopes the equatorial region of the Sun. The confined field effectively inhibits the amplification and entanglement of the Sun's primary magnetic field, hence functioning akin to a restraining mechanism that curtails the escalation of solar activity. However, in an abrupt and unforeseen manner, this specific localized field ceases to exist, resulting in the release of the brake mechanism and facilitating an increase in solar activity. The researchers referred to this significant alteration as solar cycle termination occurrences, often known as terminators. Solar terminators take place immediately following the conclusion of solar minimums, thereby coinciding with the official commencement of each solar cycle. Upon retrospective analysis of historical data spanning several centuries, the research team successfully discovered a total of 14 distinct solar terminators that occurred prior to the onset of solar maximums. The researchers observed a correlation between the timing of these terminators and the magnitude of the succeeding solar peaks. Due to limited data availability during the initial stages, the research team encountered difficulties in identifying solar terminators in each cycle. The commencement of solar cycle 24 was characterized by a delayed occurrence of the terminator, hence leading to a reduced extent of magnetic field expansion during the cycle. Consequently, this phenomenon contributed to a diminished solar maximum. The commencement of solar cycle 25, observed on December 13, 2021, had an earlier occurrence of the terminator than initially anticipated. This occurrence was interpreted by researchers as an indication of a potentially more robust solar maximum compared to its predecessor. Since the occurrence of the 2021 terminator, there has been an accelerated increase in solar activity that has surpassed initial projections. According to McIntosh, the current trajectory of solar cycle 25 indicates that solar terminators may offer the most effective means of forecasting forthcoming solar cycles. In July 2022, NASA acknowledged the research conducted by McIntosh and observed that solar activity appeared to be accelerating earlier than anticipated. Likewise, according to his predictions, NASA has not yet revised their 2025 forecast in response to the provided evidence and is unlikely to include terminators in their future projections. It is anticipated that they will adhere to their existing models. As Alexandria Ocasio-Cortez says, we don't have time to sit on our hands as our planet burns. For young people, climate change is bigger than election or re-election. It's life or death. You can suggest topics you want to see next in the comment section below. Please subscribe to Weather Collapse if you want to know more and be updated on the latest news about natural calamities or disasters happening all over the world, and don't forget to like today's video. We'll see you in the next video. Thanks for watching.